everyone, myself Dr. Triparna Saha, and on this YouTube channel we used to discuss about different topics related to AI, machine learning and coding. Not only that, we used to talk about different new ideas that you could try to do some research work. And in this playlist, we are talking about what are the research or whatever the papers I have been published so far, or some new ideas as well. For example, this particular video actually, this particular video was a research work that I am currently doing. But today I am going to talk about a work that is a published research work. This work is named as gesture recognition from Indian classical dance using kinase sensor. This paper has been published by the IEEE in this particular conference that has happened in the year 2013. Okay, so here this particular paper we are going to talk about, and the conference name was Computational Intelligence, Communication Systems and Network. Short form is CICSYN, and it was an international conference happened in the year of 2013. On that year the paper has been published. In this paper there are basically 4 authors are there. It's a collaborative research work, and I must thank to my guide Professor Amit Konar, under whose guidance I have able to complete this particular work. This work was during my MTech days. In this particular work, what we have all actually talked about, that is how to implement the e-learning system for Indian classical dance that has used a sensor known as kinase sensor. So if you are not well known about this particular kinase sensor, I would like you to check these 3 videos actually. This is the first video, that is the introduction to Microsoft Kinase Sensor, that you can find under this particular playlist. Another video is on this real-time visualization of Kinase Sensor while capturing data, that you can find within the same playlist. And if you want to know how to do the coding using this particular Kinase Sensor or whatever the data acquired by the Kinase Sensor and how to write codes on that, then I would suggest you to go to this particular playlist, that is the implementation of well-known algorithms through codes. Here this particular video, that is the skeleton generation from kinetic data. So this particular video you can check how to write code from the data captured by the kinase sensor. So let's talk about what we have done in that particular paper. So in this particular paper, you might think that this particular paper has been published in 2013. So does it have some implication in today's world in the 2020? Yes or no? Yes, it has. We'll talk about that, whatever the latest findings we have done on this particular work. This is basically one of the preliminary works that I have done, and based on this work, a paper has also been published in the Elsevier Fuzzy System journal as well. So that we are going to talk about later on. But for today, it's about this particular paper. It's a collaborative research between 2 universities, and a heartiest thanks to Professor Atul Nagor for his support for publishing this paper. So these are the content that we are going to talk about. So we are going to first talk about what is the aim of this particular work. Then we are going to talk about kinase sensor. But for the kinase sensor, I have already mentioned that I have already gave you enough about this particular kinase sensor. So please refer to those videos. Then I am going to talk about the feature extraction, what we have done here, and whatever the algorithm what we have proposed, the experimental results we are going to talk about. Then we are going to talk about the conclusion and the future work. Based on this future work part, we have developed some new algorithms in today's year as well. Then it will be about the references. So what is the aim of the proposed work? So the first aim of this proposed work is to design a e-learning system for Indian classical dance. If you are well known about this Indian classical dance, you would know that this dance form has or this type of dance form can able to depict different emotions in the terms of the body gesture. like anger, fear, sadness, happiness, and relaxation. These type of emotions can easily be depicted by these particular gestures by the Indian classical dance. And this particular algorithm, it can be developed using support vector machine. The classification can be done, and to design an e-learning program for allowing people all over the world to learn the gestures used in Indian classical dance. So you can be anywhere in any part of the world, but if you are eager to learn this type of dance form, this type of elaborate and this type of emotional dance form that has so much intricate body movements, then you can easily do this. For that, we have designed this e-learning program. So it is going to ensure a fast and cost-effective way of spreading Indian classical dance. So this is we have done using the sensor known as kinet sensor. I am not going to talk about this kinet sensor as it has been talked about in my earlier videos. Now for the feature extraction part. So for this feature extraction, as basically we are going to recognize the gestures that has been done by the Indian classical dance. So here there is a one circumplex model has been proposed by a scientist, renowned scientist Russell. He has proposed that based on the intensity and the impact, positive or negative effect of one particular gesture, gestures can be segregated into a two-dimensional space into 4 coordinates. Here you can see that anger, this particular gesture is of high intensity and it has negative effect. So this will be in this particular position, right? Now the fear is also a negative gesture, but this has much more lower intensity than anger. So fear will be much more lower here. Now for the sadness, it is negative, but it has the intensity level is much more lower. So this will be the sadness position. Now for the happiness is a positive emotion, or it by this positive emotion, positive gestures will be generated, and it has a high intensity level, so it will be positioned over here. And the relax, it's a positive and a very low intensity gesture, so it will be positioned over here. So we have talked about 5 different gestures that will be enacted by Indian classical dance. So that has been segregated into 4 coordinates by this Russell circumplex model. Now just talk about the feature extraction part. So in the feature extraction part, let's talk about these particular 3 images. These are the 3 RGB images, and these are the 3 skeletons generated by the kinet sensor. These gestures are going to depict anger gestures by the Indian classical dance. So in this anger, you can see that is the it can be characterized by fast to and fro movements of hands. So that is the distance between hand and elbow with respect to spine could be taken as a feature. Another 2 gestures, suppose sadness and fear. Here what happens? There is no to and fro movement, but the hands will come closer to the body, that is towards the core of the body. So, and how it going to depict, how the gesture is going to look, that we are going to check in the later slides. So that is anger. For anger, these to and fro movements that can be captured by calculating this particular feature. So these particular features has been shown over here. So these are the features that has been considered to understand whether it's the anger gesture or a high intensity gesture, yes or no. Now for this particular thing, these are the 3 snapshots has been taken from the video that going to depict the happiness gesture. Here what happens, the hands will go outside of the human body, or that is the core of the body, but there is no to and fro movement. Here in the acceleration, we can get these threshold values for the elbows and the hand, and for that what feature we need to calculate, that is the calculation of velocity and acceleration for hand and elbow. And based on these velocity and acceleration, if we put 2 threshold values, that is this 20 meter per second square and 70 meter per second square for elbows and hands respectively, we can easily classify this happiness gesture. Now, let's talk about the another two gestures. These are now fear and sadness. Now, in the fear and sadness that I have already told, in both of these type of gestures, our hand will come towards our human body. But both of the two gestures, that is two different, distinct two gestures, that is fear and sadness, in both of the two cases, hands are coming towards our body. But the way the hands are coming, there is a change. Based on that small variation, we can understand which gesture it is. For that, we have calculated another feature, that is the angle between head, shoulder center and spine. Right? So, this is for the fear where the angle remains almost constant with a very small variation range of around 2 degrees to 5 degrees. While in case of sadness, the variation range is as large as 25 degrees to 35 degrees. Based on this, we can calculate segregate between these two particular gestures, that is fear and sadness. Now we have talked about already 4 type of gestures. Remaining is the relaxation. So that we can calculate based on the angle between shoulder, elbow and wrist. So this is our shoulder joint, this is our elbow joint, this is our wrist joint. Based on this angle between these 3 joints, that angle can be taken to distinguish relaxation gesture from the other gestures. So what we can calculate, that is the total number required frames divided by total number of frames, and the percentage value. If that lies in between 80 to 100 degree, then we can say this particular gesture belongs to the relaxation one. So this is the total algorithm of the proposed work. Here in the first stage, what we are calculating, that is we are creating an initial database of skeletons of 5 emotions. Based on this, what in the step 1 does, it determines the acceleration for hand, elbow for both the hands. And if the acceleration for hand is greater than 70 meter per second square and for elbow 20 meter per second square, then the unknown emotion is anger, else it could be any other of the 4 gestures. In the step 3, what we are doing, that is we are calculating the distance between spine and head. And if the distance is decreasing continuously, then we are examining the angle between head, shoulder center and spine. And if that angle is again decreasing continuously, then that is for the unknown emotion, that is a sadness. And if not, that is the angle between head, shoulder center and spine are not decreasing continuously, then that is for the emotion fear. Next, we are calculating, or we are taking the percentage of angle between elbow, shoulder center and wrist, and that is greater than 80%, then the unknown emotion is relaxation, and else the unknown emotion is happiness. So here we have decide which is the emotion. Anger, here we can get the sadness, here we can get the fear, here we can get the relaxation, and here we can get the happiness emotion. To get the much more deeper insight about this algorithm, I will suggest you to look into the published paper. Please go to the paper. We are going to get much more details about this algorithm. Now these are the some experimental results have been shown based on the feature, that is spine, and that is the distance between spine and elbow left, spine and elbow right, spine and head right, spine and hand left. So based on these 4 features, how 5 different gestures can be distinguished, that has been shown here. Here you can see, that is the feature has been taken here is the angle between head, shoulder center and spine. Based on this particular feature, how the 5 different emotions have different values, that can be checked over here. So what we can conclude, that is, this is the first time, actually that particular work was the first time, so I will definitely urge you to look into this particular paper, where the body gesture is recognized for Indian classical dance style. This could be very much fruitful for e-learning purposes, and the achieved accuracy rate was 86.8% with computation time of 5.615 seconds in an Intel Pentium dual-core processor running MATLAB 2011B for a video consisting of 200 frames. And in the future, that we have already done, that is, we have worked on other more complex emotions like surprise, disgust, and shyness. This particular future work that we are currently doing, that about that I am going to talk about later in some later video. So these are some references. I would suggest you to look into these references to understand more about Indian classical dance and how that could be used to for the implementation of e-learning. Here I will just get your attention in this particular paper. That is another paper published right now. It is published where in the 2013 it was in the accepted stage. Here this particular paper that has been published in the first IEEE conference in the 2013 itself. Here in our lab group paper, here you can see we have used fuzzy image matching for posture recognition in ballet dance. Not only for Indian classical dance, we have talked about another type of Western dance form, that is the ballet dance. This particular paper was this particular paper. So this is for this today's video, and obviously I will again suggest you to look into this particular paper that is available in the IEEE Explorer. Please go into the paper, then you are going to get the much more details about the paper. Here we have already talked about the overview of this paper to get your attention, but to know much more deeper how the algorithm has been developed and what are the nitty-gritty of that, for that you must go through the particular paper. So thank you everyone for watching this particular video, and happy studying.